so you got your thing up, then we are going to kick this off. So Avideh Haghighi. Avideh Haghighi is an architect with ZGF Architects and a Living Future Accredited professional dedicated to creating a regenerative built environment through her role as designer and an AEC industry advocate. She has a diverse portfolio of work spanning public and private sectors, including public schools, mixed-use residential, and institutional buildings. Avideh's career has been equally rooted in client-serving sustainable design and advocacy for greater environmentalism in the building industry. So, Avideh, thank you so much for joining us. You can take it away.
Thank you for having me. Hi, everyone. Good morning and happy Friday.
Happy Friday.
Today I want to talk a little bit about decarbonizing construction materials. So by now, we all know that a net zero energy building doesn't necessarily mean a net zero carbon building. We know that energy, depending on what type of a grid is coming from, for example, if it's coming from a dirty grid, it could still have a really high carbon footprint, even if we offset it somehow, either on-site or off-site. And we know that a truly net zero carbon building has zero operational and zero embodied carbon emissions. So the embodied carbon part is something that the industry has been awakened to the past couple of years, and really trying to figure out how we can lower embodied carbon emissions. So why do building materials matter? So building materials have a pretty long life cycle. If you think about it, each product that gets installed inside a building, whether that's a structural material, an envelope material, or an interior furnishing, every product starts with some amount of raw materials that are extracted. This is what I call the pre-building phase, where materials are extracted, manufactured in a facility somewhere, and they're packaged and shipped to a retailer or a wholesaler. Then after the pre-building phase, we go into the building phase of the life cycle, where these products get installed inside buildings. Buildings are constructed. And then this phase also includes the lifespan of the building, maybe 50, 60 years. Some buildings is 100 plus years. So during that lifespan of the building, these materials need to be maintained. A lot of times they need to be repaired or sometimes entirely replaced. And then after the building phase, we go into post-building. What happens after the useful life of the building is over? A lot of times these materials are just simply disposed of. Some are recycled and hopefully some are reused, although our reuse rates at the moment are pretty low. And when we were looking at operational carbon as an industry, our efforts have been focused on reducing operational carbon. That's really only happening during the building phase. Where the building is operational, it's occupied, it's functioning, all the systems are running, and therefore there's carbon being emitted depending on what types of systems are in the building. Whereas embodied carbon is emitted throughout this entire life cycle, way before there is a building even in place and in question, and way after that building as well in the afterlife. So cumulatively, embodied carbon adds up. If you look at the whole life cycle, it adds up to be a lot more carbon emissions than operational carbon. And I'm sure all of us at this point have seen those wonderful Architecture 2030 graphs showing the cumulative impact of embodied carbon, especially in the next 10 years with reducing emissions by 2030, and how that's a really important piece of the puzzle that we need to crack. And I want to add that our current EPDs, environmental product declarations, are actually really capturing the pre-building phase. These EPDs are our primary source of transparency documentation at this moment, and that we're using to evaluate a product's carbon footprint, and yet is only capturing, most of them are only capturing the pre-building phase, which does include extraction and manufacturing, which does happen to be the highest carbon emitting life cycle stage. But the building stage also has a lot of carbon emissions. So let's look at that. Let's look at the lifetime of the building. I like this graphic and this idea of looking at a building with these different layers, like an onion where you peel the layers back. And each of the layers in a building have a different lifespan. So if you look at the building from the exterior, the envelope and the structure have the longest lifespan. There are buildings over 100 years old, couple of 100 years old, that are still standing on the original structure. But then when you look at the more interior layers, such as the space planning, the program of the building, the use of the building, whether it's an office building or a school or a clinic, determines how the interior space of the building is planned out. And then if you go one more layer in, you're looking at fixtures, fittings, furnishings, furniture, things that are not necessarily fixed, that are easily replaceable in a building. So the more interior you go in these building layers, the shorter the lifespan of these materials are. And therefore, the faster they're going to get replaced. So I like this chart from the Carbon Leadership Forum. They did a study of some buildings, mostly in the Pacific Northwest. So the sample study for this was small, but nonetheless, this gets the point across. We're looking at the three boxes that you're seeing. The left box is the lowest estimate, the middle box is an average estimate, and the right box is a high estimate. So let's look at the middle estimate. On the middle estimate, you see that the light gray box at the very bottom is just emission from initial construction of building materials at the point of initial construction. Then the red, and this is over a 60-year lifespan, and you see 15-year markers along the graph. So assuming every 15 years, there's some major mechanical renovation, MEP renovation, or retrofit, then the embodied carbon of that adds up every 15 years. And then assuming that also there is some TI fit out, for example, primarily commercial buildings, then there's also the embodied carbon associated with recurring TI fit outs. And you can see if you add up the recurring TI and MEP fit outs over the lifetime of a building, it ends up being more than the initial construction embodied carbon. So that's why I think.
Well, just to clarify for folks, that you mean TI is tenant improvements and MEP
Yes.
is mechanical, electrical, plumbing? Got it.
Yes, tenant improvement. Thank you, Sean. So this is the piece that right now is missing from a lot of our studies. We don't have a whole lot of data, as I mentioned. This is the first of its kind of a study that the Carbon Leadership Forum has taken a crack at. We do need more data on this, and we do need to get a better picture of embodied carbon over the lifetime of a building, which is where our whole building life cycle analysis studies come in. But in a building, there's a lot of materials. There's thousands of products and materials that get installed in a building. So as architects, we've been finding it a bit daunting of, okay, well, where should we spend our efforts on? What should we prioritize? So we have come up as an industry, we're starting to come up with a list of high impact materials. These are materials that either we use a lot of in buildings typically, or even if volume or weight wise is not a lot compared to other materials, the carbon footprint is so high that it ends up being a high impact material. So some of these materials include concrete, steel, insulation, carpet, even drywall. And Architecture 2030 has developed some great guides on each of these materials and how to reduce embodied carbon, and a link to that is at the end of my presentation. Then we also have to look at high impact MEP components. And this is the part where we really don't have a lot of data on. Air handling units, ductwork, which is often made of sheet metal, cast iron piping, refrigerants are extremely high carbon emitters that we need to start looking at identifying and replacing in our buildings. So that was the carbon side of things, the carbon impact of building materials over their lifetime. There's also a social impact at every stage, every life cycle stage of a material. So let's look at that. In every material, it starts with the extraction of raw materials, right? So at the point of extraction, usually these manufacturers and facilities are located in low-income communities. Usually it's communities of color, what we call fence line communities. And these communities are typically within a couple of miles of a manufacturing facility. And at this point, 40% of the US population lives within a fence line community where high-risk chemicals are extracted or manufactured. These fence line communities are at a risk of acute or bioaccumulative cracking runoff and off-gassing exposure. Then when the material goes to a factory to be manufactured, there's the risk of factory workers getting exposed to chemicals, toxic chemicals, and off-gassing. OSHA has actually set exposure limits, for example, for formaldehyde. In terms of the amount of time and the amount of exposure that's considered acceptable and non-hazardous, let's say. However, if you compare these thresholds with thresholds that, for example, building standards like LEED and WELL set, we found that the OSHA standards are 47 to 104 times higher than the thresholds are higher than LEED, which means it allows for 47 times or 104 times more exposure than LEED or WELL would allow. So that's a real concern. And factory workers suffer from respiratory problems to a variety of cancers and fertility issues. And they have some of the greatest acute exposure rates of anyone along the supply chain. Then when the material is installed inside buildings, there's still off-gassing that happens. A lot of times the argument is made that, well, the toxic chemicals inside materials are inert by the time they get installed in a building, which means they're encapsulated inside the product and therefore not exposed. But there's still great risk of bioaccumulative effects that can take a toll on end users and building occupants. There's still off-gassing that happens. We all know about that, paint and adhesives. And that results in indoor air quality typically being 2 to 5 times more hazardous than outdoor air quality, which is shocking, especially, I live in LA, we've got a lot of pollution, and it's really hard to wrap your head around how indoor air quality could be worse than polluted air outside. And then at the end of the life of the building, though we hope it never happens, the fact is buildings do catch on fire, or there's some natural disaster that happens, a flood or a hurricane, and we have first responders showing up on site. And these first responders are actually at a 14% higher chance of dying from cancer. And this figure comes specifically from firefighters. All those wonderful chemicals that are locked inside building materials, once the building catches on fire, all of those chemicals are released. They're burning. They're releasing a whole lot of toxic gas that even the PPE that the firefighters are wearing aren't protecting them against.
Thank you.
So,
by the way, I just want to say thank you for this slide. This is so powerful. Thank you.
Of course, yeah. This is a powerful slide because it just kind of gives us a sense of the scale of this impact. And as architects and designers, for us, it's really hard to grasp this because it's so far away from us, or it happens on such a different timeline, right? We design something today, the fire may not happen for another 50 years, and we forget that that building is still out there, is still going to have impact on whoever comes into contact with it. So now there are some common properties of high impact materials. Remember when I talked about let's identify high impact materials, because there's no way we can get a handle on every little material, but if we prioritize, we can reduce carbon emissions. Most of the high impact materials we have identified at this point actually have some things in common. They're made of synthetic or semi-synthetic chemicals. These chemicals are typically made from fossil fuels, and these products and chemicals are typically combined with other additive chemicals that are toxic. So for example, insulation is a material that we have as an industry identified as high impact in terms of embodied carbon. Well, guess what? Insulation also is made of synthetic chemicals these days, not unless you get, sheep's wool insulation, which is made from fossil fuels. And insulation, especially if you look at bat insulation, for example, oftentimes has added formaldehyde. As an industry, we're phasing that out. There are manufacturers that are taking some great steps to take out the added formaldehyde. But that's just one example where the nexus of low carbon, decarbonizing building materials meets with our goals in terms of reducing social impact of building materials as well. So it just so turns out that the materials with the highest carbon impacts are also the ones with the worst social impacts throughout their life cycles, which is great for us because now we know exactly what materials to prioritize. So we're talking about chemicals. Let's dive a little bit deeper. I'm going to keep going deeper and deeper. This is a study that was done by the Healthy Building Network in conjunction with a couple of other nonprofits. If you have not heard of the Healthy Building Network, please look them up. They're doing some amazing work. They're a nonprofit, and they're really exposing the chemical industry in building. So they studied what they categorize as high risk factories, high exposure risk factories across the United States. The factory that was the highest risk was chlorine factories. Actually, there's a ton of them in the United States. They are very high risk factories. Chlorine is actually a very dangerous, it's chlorine itself in liquid form, like chlorine in our pool water is not dangerous, but in chlorine gas, when it turns into gas form, is actually very poisonous, highly explosive, especially when it's combined with other chemicals like ammonia or turpentine. So let's look at where these chlorine factories are. As you can see, this is mostly all these factories are in the Gulf Coast of the United States. Here's another map that the Healthy Building Network put together of where these factories are located. And this is just a great visual and a great reminder that these days we tend to think that materials are manufactured outside. They're manufactured in China or somewhere else, and they're shipped in, and therefore there's nothing we can do about the supply chain. But when it comes to chlorine, for example, we have a lot of these factors right here in the United States that are impacting our communities every single day. So what is chlorine used for in building materials? It's used to make stuff like vinyl, PVC roofing, and PVC gaskets and components in buildings are all made from high amounts of chlorine gas. Essentially, chlorine is used to make plastics in buildings, and there's a lot of plastics in our buildings these days. In fact, the petrochemical industry is targeting that plastic resins used in the construction in the building industry is going to be one of their highest sources of recovery economically. as more and more energy is diverting to clean energy, diverting away from fossil fuels, the petrochemical industry is desperately looking for the next industry or the next thing that they can recover from. And guess what that is? That's the building industry. So right now, construction industry is the second largest consumer of plastics. That's right after packaging industry. USA and China account for more than half of the world's PVC and chlorine production. So I want you to think about that. That's more than half of the world's. We are supplying PVC to the rest of the world. In addition to that, 70% of the PVC that we manufactured in those very same plants along the Gulf Coast, 70% of that is used for building products directly. To put it short, vinyl is lethal. Vinyl is the only plastic and the only major building material that is made from high volumes of chlorine gas. It's an unfortunate domino effect because the more we use vinyl and these plastics in our buildings, the more we're driving demand for these chlorine production facilities that are creating harm in our communities. Vinyl production requires consuming more than 40% of the chlorine gas produced in the country. It's the largest use of chlorine gas in the world. If you want to compare it, about only 5% of the nation's chlorine gas is used to disinfect water, for example, compared to 40% to create vinyl products. So this is a clip. It features a man outside the Denka processing facility. It's a neoprene producer in New Orleans along the well-known Cancer Alley. I think at this point we're all familiar with Cancer Alley, which is 85 miles of petrochemical plants, many of them manufacturing the PVC that is used in our buildings. These communities are predominantly Black. They have a 50 times higher risk of cancer. And for that reason, PVC is in fact called poison plastic, because it's not only the manufacturing process that releases highly toxic chemicals, but it also harms the end users who come into contact with it. Really, throughout its entire life cycle, there's not a point for PVC that is looking good. So let me see if this can work.
Something is
Do you hear the audio?
killing us. It's a terrible thing to watch people have cancer and realize the suffering that they're going through, and to realize that you could be next. Welcome to Reserve, Louisiana. This is the cancer capital of the United States. But we know that people in this little town is suffering at a cancer rate that's 700 to 800 times that of the nation.
We're in what's known as Cancer Alley in Louisiana, an area between New Orleans and Baton Rouge lined with petrochemical plants and refineries. Most of the towns here are poor and Black with extremely high rates of sickness and suffering. Robert Taylor has lived here all his life, and he's surprised he's made it to the age of 77.
And my mother got cancer. My brother died of lung cancer. My sister's son died of lung cancer. My wife got it, my daughter. When it wasn't close relatives, it was the next door neighbor and the people down the street.
He's currently in a legal battle against a large chemical plant a few blocks from his house. It's the only plant in the U.S. which makes chloroprene, a chemical the EPA says is a likely carcinogen.
I think the emissions need to stop. I don't think that human life should be subject to the profit motive.
What chloroprene goes to make is the neoprene material that goes in wetsuits and laptop covers. It's more of a product that's made for people's recreation.
Well, that's a part of the humiliation that we suffer We don't even have a swimming pool in the black community. The predatory attitude that the powers that be have toward black people has not changed since slavery. The methodologies and whatnot changed, but the effect in all of this is still the same. We're still deep in slavery in America.
Reserve was once a thriving black community post-World War II. Robert's parents and many others were drawn to work in the large sugar refinery or farming the surrounding sugarcane fields. The sugar company closed in 1985, and now petrochemical companies have bought out much of the town because of its proximity to the Mississippi River, highways, and railroads. All that's left of Robert's childhood neighborhood now is this cemetery, which is ironically filled with Robert's relatives who mostly died of cancers linked to the emissions.
All of our ancestors here now are covered by this monstrosity here.
So you have to visit from here.
I had to either visit from here or I can't go on that property without, I can't even walk across now to go into the cemetery.
This is the cemetery. Across the tracks, this is where I was standing with Robert. Petrochemical companies own all of the surrounding land.
My mom and my dad in there, brothers and sisters, uncles, aunts, my grandfather. But how do look what I've got to go through. Look what I'm up against, just trying to come and visit with them.
Okay. So this was just a short clip of a longer clip, and I have the link to this at the end of my presentation now. Let me go back here.
Something is...
I had another clip. This is about Robert Town. There's a link to this at the end of my presentation too, so I'll skip this for now. And I'm coming up against my time, so I want to just close with this slide. I do believe that the building industry is stuck in this cycle of perpetuating social injustice. As long as we continue business as usual, as long as we continue using the same products, we are, whether we like to admit it or not, perpetuating just this social injustice that's happening along the supply chain. And we really do need to be doing better. So here's some resources of some of the things that I talked about today. We have a long way to go. There's some great progress being made already in terms of asking for transparency certifications and trying to measure social impact of building materials. And I hope that we can build on that and keep making our buildings not only healthier, but more socially just through the materials.
Woo!
What's that?
Oh, man, it's heartbroken first thing in the morning. Jeez.
Yeah.
Thank you. So there's some questions in the chat. Just, some of them back at the beginning about carpet and low embodied carbon scenarios that you're discussing. But to address the most recent work, the last part of your presentation, specifically about vinyl and the impacts of chlorine-derived compounds generally and where they are and the impact. So what the Healthy Buildings Network, and I think it would be the Red 10 that's out of the International Living Future Institute that you're a fellow of, right?
Red list, yeah.
Red list. Is it 10 or 12? I don't recall.
The red list is actually about 800 plus chemicals. It's a long list.
So maybe there's like a top 10 that they give out. And you go to
There's a top 10 that they highlight, yeah. Yeah.
So tell us a little bit about your work in addressing this in your design practice.
Yeah. So right now, because these connections are so hard to make for us, as I mentioned, on our everyday practice, when we're choosing materials, a lot of times we say, well, we're choosing from what's available, and this is only what's available. So the first step for us really is to connect the dots and make sure that everybody is educated on the fact that these materials have these impacts way before they get to the building and way after they leave the building. and encouraging our designers at ZGF. Right now, we're coming down hard on vinyl and PVC specifically for this reason, is to say that, you know, there are alternatives. There are easy alternatives. Like we specify luxury vinyl tile all the time. We don't have to. There's other flooring that doesn't have vinyl that has the same properties, that's cost effective, that's readily available, because that's a big part of it, right? Same thing goes for our PVC roofing. There's no reason we have to be using PVC roofing. There's equally comparable products out there right now. They're industry standards, and we could simply just switch to those. And by doing that, inherently, we're saying no, we don't want more chlorine factories. No, we do not want more communities impacted. Yes, we want better practices, and it's not to say that, for example, EPDM roofing is so much better. It is better. It's still another form of a plastic. I don't think we have complete solutions yet, but we're taking those small steps to choose better and better materials. Ultimately, the best materials are the ones that don't have any petrochemicals in them, any synthetic chemicals in them, right? Those are the natural materials.
Would you be willing in the chat to continue this? Ram is waiting, but I wanted to, the thing I'm hoping that you'll address is some of the things, the actual materials that you would substitute, like composite vinyl tile, it's marmoleum or blank. Would you be willing to chat a little bit about some of the alternatives that you've arrived at that were cost effective? And note that
Sure,
there's
yeah.
people who've left their email addresses or like, please send me your slides. So I told them, oh, put your email address in the chat, and Avideh will respond to it.
Yeah.